Let's say you plug your data into SPSS. SPSS is going to give you two important boxes of information. This first box here tells you what you entered as far as your observed frequencies. Here it says observed N, but N is just it's like a sample size, right? But you counted people, so it's still a frequency. Right? So the observed N is the same thing as what was the number of people in each category, in other words, frequencies. So it's always good to look at this table to make sure that you did everything correct, okay, that you entered this data in correctly. Then SPSS will calculate what you should see as far as expected frequencies are concerned. And you don't have to calculate this. SPSS, if you tell it, test the hypothesis that all categories are equal, it will actually run this calculation for you. So that's kind of nice. And then the residual just tells you the difference between what you counted and what you should have found, right? What you should have found if, in fact, your observed frequencies are distributed the same way as some other set of frequencies. So if our GRE data is distributed like the NGTA data, then for this cell below 500, we should have seen 30. But we didn't. We got 16. So we were 14 under what we would have expected. Here, we're 30 under what we would have expected. Over here, we're 50 over. And down here, well, we were very close, okay? We're just 6 under. All right, now, the question becomes, are the two distributions distributed the same way? Right? That's what we're trying to find out. So to answer that, we go to this next box. And we look at the value of chi-square, 60.80. Well, that's huge, right? For a test statistic, that's a very, very large number. The degrees of freedom were 3, and no surprise, the sig value is less than 0.05, so it's significant. This number here, 60.80, is significant because this is less than 0.05. And I would have predicted that because, again, 60.80, that is a huge number for chi-square or for any test statistic. It's just a really, really big number. And remember, the larger the TS value, the more likely it is to be significant. So the way we would write this in APA format is we would say chi-square, and remember this is a funny looking X. It is not a normal X. And then this is a superscript, which means it goes above, right? So subscripts go below and superscripts go above. So chi squared, and then in parentheses, you put the degrees of freedom, which we learned are 3. So that goes here. And then a capital italicized N equals, and then your total sample size, 200. Okay. Then an equal sign, the actual value of the chi-square, so 60.80. Remember, take it to 2 decimal places. And then a comma followed by a lowercase p equals, and then this is your sig value, so 0.000. Now, I often ask you for the actual sig value. I don't want you to just say p greater than 0.05 or p less than 0.05, because I want to make sure that you know what the actual sig value is and that you weren't just guessing. Because you have a 50-50 chance of getting it right? Because you're either going to say p is less than 0.05 or p is greater than 0.05. That gives you a 50-50 chance. But for me to know whether, in fact, you knew where to look for this p-value, I need you to report it to 3 decimal places, right? Okay, so just a little bit of trivia here. Not everybody likes for you to report sig values or p values as 0.000. I don't have any issue with it because for statisticians, p.000 is not the same thing as saying p is 0. We're saying it's only 0.000 to the third decimal place. There could be a 1 here, a 2, a 3, or a 4. But we don't care. All right? We're only going to go to 3 decimal places. But some people don't like that. They say, oh, you should put this as a 1. All right? Don't do it in my class, but just so you know, FYI, you might get somebody down the road who will not like it if you report a sig value or a p value as 0.000. Okay, so obviously from this result, we see that there is a significant difference between the F observed and the F expected. Okay, so what I'm saying is the significant means that F observed is not the same as F expected. I am not talking about X bar here. I'm explaining what the word significant means. Okay, so to be significant means that your observed frequencies are different from your expected frequencies. So now you can't stop there. You have to explain, okay, so you just told me that the two distributions are different, but in what way are they different? And so what you're going to do is you're going to go back up to this table. And I find it helpful to look at the residuals. The residual, another word for residual is error. In this case, though, what we're saying is each residual is telling us how far off the mark we were, right? So here you can see 30 is like your mark. It's your bullseye. That's what you were aiming for, but you were under by 14, that sort of thing. So I start where I see the greatest discrepancy. The greatest discrepancy here is for almost the highest category, right? SUU, if we're talking about SUU, had far more people score in that highest category than what we would have expected, according to the NGTA data. So it's like, whoa, I'd want to emphasize that and say, you know what? Overall, we're doing better than the national GTA data because we expected 60 and we got almost double that scoring in this high category. So awesome job. Now, there were fewer people in the category below, but that's probably because those people ended up getting a higher score. Right? So to say that you're below what was expected for this category isn't a bad thing if you explain that, yeah, it's because more of them were here. More of them scored high. We were a little bit below what we would have expected in this lowest category. And again, that just shows us how smart you guys must be, because normally we would expect 30 to be in the lowest category and there were only 16. And, for this top tier category, we were a little bit below the NGTA data, but hey, for the most part, SUU did really well on the GRE, okay? So you would phrase that a little more formally. You wouldn't go, but hey, right? So you would say that overall, SUU students scored, higher than the expected distribution. Okay, according to the national NGTA, more students scored in the higher category and fewer students in the lower category, something like that. Now, just going to point something out. If you look here, we can see that we have satisfied one of the assumptions for the chi-square test. Nobody, that is none of the cells, none of the categories, whether it was below 500, 500 to 599, etc., none had an F expected less than 5. And we can look up here and we see that. You see it goes from 10 all the way to 100. None of these are less than 5. So we have met this assumption.